Hi everyone, thank you for having me. My name is SYAFFA'AFIQAH AZHARI and other three member which is Hoking FATT, Chai Sunyan and Ahmad Zairy bin JAMALUDIN. So I'm going to be speaking to you today about introduction, which is the internal resistance to flow of a fluid under gravitational force is measured by kinematic viscosity. Is it calculated by measuring the time in seconds necessary for a fixed volume of fluid to flow a known distance to a calibrated viscometer at a carefully regulated temperature? So basic about kinematic viscosity is the ratio of dynamic viscosity over the density of the fluid. Now look at the left side, which is objective of this project. First is to understand this concept of kinematic viscosity measurement and to figure out the viscosity index of the lubricant sample. So I will pass
Okay,
to my friend.
okay, thank you explanation from the ICA. Then I will explain about the methodology for this kinematic viscosity. So you can see in the poster, we are already show that the one procedure in the kinematic viscosity of sample oil determination procedure. So before we start to doing this lab, we must prepare the equipment and material, which is the Gitiwa viscometer, glass beaker, and sample oil. After that, we need to take and hold the viscometer and put out the sliding plug to make sure viscometer tube and steel ball clean and put back in. And then we put some the oil sample into the glass beaker and then hold the viscometer vertically and select breathe up and put up sliding plug. And then we will fill the oil sample to the viscometer until very above the V black inside the viscometer. And then we will push in and rotate the plug slowly back in and let the valve open to breathe the oil inside until the all air expeller, and after that tighten the valve. And then after this we will key in and do some setting, which is we will before that I'll focus on that. Before that we will connect the power cable to the viscometer and turn on the power supply before we will setting the parameter. And then so when we do the key in and setting the parameter, we will select the move one, use the speed and arrow key to input the oil density. After that, we will select the move 5 to press return and set new oil density. So after that, we will also to select the temperature to 40 degrees Celsius and confirm this using the return key. And then the next step is we will follow the instruction from the viscometer, which is when temperature of 40 degrees Celsius is reached, we need to tune the viscometer every time when the tune instruction to promoted on display, and after that the display will show the viscosity of the oil sample. After that, we will record the oil sample data when using the up arrow key to toggle the display from the 40 degrees Celsius to 100 degrees Celsius. And follow the tilt instruction again when it promote on the display, and after that the display will show the viscosity of the oil sample. So when we done the taking the oil sample data of viscosity for each oil sample, we will turn off the power supply and disconnect the power cable, and then we will slowly pull up and rotate the plug to open the viscometer, and we will almost can and remove the oil sample into the beaker so that the steel ball do not fall up. And then we will clean up the viscometer tube and steel ball and put back the steel ball into the viscometer. After that, we will clean up the workbench with solvent such as the acetone to remove the oil stain. So when we take the basic data of kinetic viscosity, we will calculate the viscosity index of the sample oil. So we will base on the STMD 2270 standard. So in this lab, if the kinetic viscosity of the sample oil at 100 degrees Celsius is less than or equal to 70 meter square per second. So we will extract from the table one in the poster. I already showed that when the corresponding value from L and H. L is meaning that the kinematic viscosity of 40 degrees Celsius and oil of 0 viscosity index. Well, the H is the 100 viscosity index respectively. So if U larger than H, we will calculate the viscosity index using the equation B in the poster, the first one equation, which is the VI equals to L minus U divided by L minus H multiply 100. If U are smaller than H, we will calculate the viscosity index is using the equation is VI equals to bracket and bracket again. The inside bracket is n d log n minus n divided by 0.00715 and multiple 100. So it's about the methodology for kinematic viscosity. So the next part will explain for my friend. Thank you.
All right, so my name is Chai, and I'm going to explain about the result and discussion for the kinematic viscosity experiment. So as shown here, the table one is the readings we obtain for the viscometer and also how we get the viscosity index from the readings. So there are two samples here, and the first one is the kinematic viscosity at 40 degrees Celsius, and second one is the kinematic viscosity at 100 degrees Celsius. So for this reading, we obtain from the viscometer and repeat for 3 times to get a 3 reading and obtain the average reading for this kinematic viscosity for both sample A and B. And after that, we use the kinematic viscosity of at 100 degrees Celsius for both samples to find the values of L and H, which is the kinematic viscosity of 40 degrees Celsius for the oil of index 0 and 100. So after we get the value of L and H, we substitute back to the equation of calculating viscosity index. So we get viscosity index and we round it to the nearest whole number because it is decimal form following the STM standard. So finally, we get the viscosity index for sample A is 100 and viscosity index for sample B is 101. So after we obtain the viscosity index, then we need to determine the possible SIE viscosity grade for the engine oil. So SIE is referred to the Society of Automotive Engineers. So the viscosity grade is important because it will determine the vehicles to run smooth and keep the engine cool and avoid damage to the engine. So from here, we use the kinematic viscosity at 100 degrees Celsius for sample A and sample B to determine which grade is the engine oil. So from the SAE J300 table, we can see the kinematic viscosity for the sample for both sample A and B, which is 7.6 and 7.8 is lie between the range of 5.6 to 9.3, which is referred to the grade 20. So we can say both sample is in SAE 20 viscosity grade. So this grade is a monograde oil, and is function suitable for summer season because of the higher viscosity and thicker to protect the engine in the higher temperature surrounding. So next, we done the assessment on the samples, also based on the viscosity index. So we can say both sample A and B may be refined oils. This is because the most refined oils have a viscosity index about 100, and for higher viscosity index like 150, that will be synthetic oils or multi-grade oils. For lower viscosity index, that could be a refrigerant oil or so on. So we conclude that sample A and sample B may be a refined oil based on the viscosity index we get. And from the graph shown below, it shows the relationship between viscosity and the temperature for different oil with different viscosity index. So we can see the higher viscosity, the oil with higher viscosity index will show the viscosity to be more stable over a wide range of temperature, and the lower viscosity index oil will have more sensitive, or the viscosity is tend to change over the temperature, so it's not stable compared to a higher viscosity index oil. So from here we conclude that the viscosity index, the higher is the more desirable engine oil. Okay, so that's all from the result and discussion for this kinematic viscosity experiment.
Okay, thank you, Chai. Hello, my name is Ahmad Zairy bin Jamaluddin, and I'm going to present about the conclusion for this case study, kinematic viscosity. So, number one, viscosity index determination method. So, in this case study, we use our calculation based on formula in ASTM D2207 standard. Number two, viscosity index of the sample for this case study is, for sample oil A is 100 and sample oil B is 101. Number three, the grade of lubricant oil based on the viscosity index for sample oil A and B. So by following SAE J300, both sample of oil A and B are graded at SAE 20. That's all from our team. Thank you.